Alright, welcome back to Meteorology 101. Visit my website, meteorology101.com. This video, I'm going to talk about the software. I've gotten a couple of requests for what I use for storm chasing, forecasting, weather charts, stuff like that. So, this is the main program for downloading weather charts, surface charts, upper air charts, and then some thermodynamic charts, stuff like that to actually forecast from. So this is digital atmosphere. You can buy this software at weathergraphics.com. I'm not affiliated with that website, but I will give them a plug that this is a very good program to have. So there's a lot to this software. This software was developed to do a lot more than it's capable of at this time. I believe it's still in development. So right now we're just going to use it for charts, and then we do have some scripting, notepad scripts that we can run and create charts automatically. So it saves a lot of time. But for right now we got to download data, and we do that with this little satellite dish. Now we'll go through this thing real quick. I'm not going to touch every aspect of this thing. I use a lot of it, but I don't use some of it. So, file, update all work charts. If you want to update the map that's on there, start a new work chart, import directory, import grid data. That is for model forecasting. This software has a little trouble with that. There's a lot of broken links within that. Import historical data. You can actually go to weathergraphics.com, go to the software page, and you can download a file that is all historical data, and you can go back, I think, to the 1950s with some weather data they've saved. Import hurricane models. That's experimental. I don't really use that. Clear the data directory. Font mode. You got true type font. You'll see when we plot the weather station plots, you'll see the font there, and then you have the raster font. That's a old school font. You can change that too. So just gonna wiping my screen off there. Let me get back. Quality control. Not sure what that does. I don't mess with that too much. Print setup. I guess I'm printing something. So calculator. Now you can use this calculator for to convert Celsius to Fahrenheit, Fahrenheit to Celsius, Celsius to Kelvin. Pretty much most of your conversions that you would have to do. So that comes in handy. Warning status. If there's any warnings out there, sometimes it'll plot those warnings. We got to download data first. Live chart retriever. I haven't had real good luck with this thing. You can actually go, all these links, a lot of these links are broken, but if you can find the links to the chart you want to download, you can actually go and edit a file and within the software, and then they'll come up on this list, and then you can download charts. I use WeatherPipe is another software from the same developer. It's found on weathergraphics.com. That's the one I use for my charts. It works. It's a lot better than this one. Station tables. I don't use that at all. Check for updates. That really doesn't work. I mean, you can go to help and then about, and then it'll tell you what version, 3.32. I believe that's the latest version. But you can visit the website weathergraphics.com. Go to software and see if you got the latest version. Usually, if you buy the software, he'll send out an email. There'll be some clue to an update coming out. Preferences. You can pretty much change a lot of parameters within this software. What colors you want these outlines to be on the United States. What color you want the ocean to be. How do you want these station plots to be set up? I pretty much leave them. They're pretty much default the way weather stations plot their station plots on weather maps. So I leave all that stuff. I don't change pretty much any of this. The only one I change every once in a while is analysis. If the contours or isobars get too tight or too loose, then I will go adjust my width, the X and Y coordinates, and I'll change that to like 35 or 25. Adjust with that to give it either a tighter contour gradient or a looser contour gradient. That's about the only thing I mess with in there. You can download the PDF user manual on this, and if you read through that manual on the software, it is pretty thorough on what you can do with this. So map, if you have anything plotted, we'll throw. This is old data, so don't pay attention to this, but you can erase map, load a new base map, save base map, generate base map, blank map, import map from file, URL, import a shapefile. Shapefiles like your counties, all that stuff, and then you can actually zoom into one state. You can actually create a map for your state only, and then you can import the shapefile and show all the counties on that stuff. You got the overlay too. Let me go back there to add overlay. You could add the county outlines, the names, highways, all this stuff. A lot of stuff you can do with it. I could pretty much leave everything default. So you can import a directory, print. That preferences is the same thing we found on the other screen. This retrieve data, that's where you're going to download your data, the updated data, which we haven't done yet. We'll show you that in a minute. Load a map, erase a map, like we want to erase it. Then you got your overlay plots. This is station plots, and since I'm at 99%, this is going to take a minute to process, and it will be way crowded whenever you're to read it. It'd be mostly black, so I shouldn't have hit that at 99%. I usually take this down to 85% before I do that. So we got we're gonna have to wait just a minute for this to reset, because you really can't do anything else with the software until that plots all that data, and then we can erase it. So it usually just takes about 1 minute. Sometimes less, depending on the speed of the software, speed of your computer, the processor, all that. So click that's not responding. It will respond here in just a second though. We'll show you lat and long as you move your mouse over the United States or anywhere on the map. It will show the lat and longs at the bottom. There's your calculator. You can zoom in, zoom out. Now see, that's every station plot that's been downloaded. So like I said, this is all old data, so being at 95%, 99%, you're not going to be able to read all that. It just overlays itself on all that station data. So we're going to go ahead and knock it down, like I said, about 85%. Generate map. Orthographic map, polar stereographic, Mercator. I use that one, the Mercator. You can download those raster charts. That's more for aviation, airfield, stuff like that, to show you all the different data pertaining to an airfield. But I usually use the Mercator, and then I use... The only other thing I change is down here. Location preset. Go to the United States, and then I'll do zoom, level, subsynoptic, and that will get me to the map that you see. You'll have to zoom out once, I think, once or twice to get to this point, but I leave it so I can see the whole United States. Plus, I do an overlay with National Weather Service radar. I can do an overlay on this map, and it comes pretty close to these outlines. So that's the reason I use this size map. Alright, so for downloading data, we're going to go to Retrieve Data. That's going to pop up a window, and then you got the Northern Illinois University, College of DuPage, Weather Graphics, and the National Weather Service METAR data. Those are the four that I use, and then Australia, if you live in Australia, you can download that surface data, radiosonde data from the colleges, from Northern Illinois University, UCAR. That's where most of the radiosonde data comes from. I don't typically use that. We can. This data is going to be your upper air charge. You're going to use the weather balloons that they let go every 12 hours. Download that data, and then that's what the data is going to use to plot the standard levels, the upper levels, 925 millibars, 1000 millibar, 850, 700, 500, 400, 300, 250, 200 millibar levels. So you can go up to 100. Right here is your surface, is where we're at right now. So anything I plot on this is going to be surface data. So you can click on that drop down arrow and then pick what level you want. We'll have to do that after we're done with this. So I use high resolution frontal bulletins in CEP. Those fronts are okay. You can draw your own fronts too. Sometimes the computer just doesn't generate fronts very good for that from that NCEP site, but that's pretty much all you got is that, or draw it yourself. They give you a pretty decent idea where the fronts are, but you have to analyze data. Always analyze data to verify where your fronts are, where your system, your low pressure centers, your high pressure centers are, to actually understand what's going on with the weather map. Convective outlook data from the SPC. I haven't really got that to work. There is a couple plots it might put on here, outlines and stuff, but it's not going to download that the SPC chart and overlay it on this map. That's not going to happen. So I typically don't use that. Hurricane models, once we're in hurricane season, then we'll start downloading that. I usually use the UCMET data, and then you can the National Hurricane Center data. And then you can go Pacific for typhoon, and then cyclone tracks for South Indian Ocean, North Indian Ocean. So I only use that very minimal of this stuff for a download on this chart. I don't go after that too much. This software pretty much works great over land. Doesn't do so great with a hurricane or low pressure system, very intense low pressure system over the water. We'll actually label it as a high pressure system. So I don't know why. Just surface data, real time data is what it needs, and the data over the ocean is so sparse it just doesn't plot very well. So we're going to go ahead and retrieve our data. This takes about a minute too. I got 13 items that we're downloading, and then it's got to process that data, decode it, and then we'll be able to use that data for weather charts. So right now, you can't do anything else until this is finished. Completely done processing. And you don't want to leave the screen because sometimes you'll get an error. One of those links will be dead for a second. Something didn't update, whatever, and then you'll get an error. And then if you leave the screen and then you come back, you'll be sitting there with an error. Then you have to hit OK and then wait for everything to download. It takes a lot longer. So I usually watch the whole thing, at least download, and then let it process. It doesn't take very long. So I do put my logo on there. You can actually right click on the screen. You can upload put logos into a certain folder on the software, and then just create a bitmap file, and then put them in that folder, and then you could right click, and then it'll give you that selection to put your logo, clouds, any other kind of weather logos that you want on there. I usually got just charts labeled to label my 850, 700, 500. But what I've been doing lately is I use scripting. Actually, I run one script. It creates and exports all the upper air charts that I use, and then puts them on my desktop. So it doesn't really label anything. Okay, so we went back to the plus sign here, so we're everything's processed. We're on the surface chart. We could go surface, we could go all the data, 20 minutes, 30 minutes, 1 hour, all or manual. So I typically leave it on all. If it gets a little cluttered, like with a low pressure system looks out of place or something, then I'll change that to try to narrow it down. Now the upper air data, I always leave on all. There's really no sense in changing that. You only get really upper air data every 12 hours anyway, so you can it could try to use processed data from some forecast SCOOT data or something like that, but it really doesn't work. So I just leave it on all and don't change that one. Then the forecast, I just leave it on analysis, because if you go all the way out to 192, that's for your grid data that you download, and then that really doesn't, like I said, all the links, most of the links are broken. A lot of that stuff doesn't work, so I just kind of leave that alone. Now, SLP, we're on the surface. Sea level pressure, that's going to plot your high and low pressure centers. Fahrenheit is going to plot your isotherms in Fahrenheit, and then Celsius obviously is Celsius. Now, I use Celsius because it is every 2 degrees on Fahrenheit, every 2 degrees on Celsius, but if you go every 2 degrees on Fahrenheit, those lines are so close together. Sometimes I'll use it just to try to get a good look at the thermal advection or something like that, but very rarely I use the Fahrenheit on the surface, which weather charts don't plot isotherms on the surface chart anyway. I do, just so I can see the thermal advection. Then I'll run a script for a thickness chart. I want to see thickness advection there to place my thermal advection, place my fronts, stuff like that. So let's go ahead and build a surface chart. We're going to use sea level pressure. Then I am going to use the isotherms. So you can see we got 2 lows there, low over here. So we're troughing, ridging, troughing, ridging, troughing. So it does kind of place different low centers. You got a 996 low pressure center there. You have to actually look at the data to see where that low pressure actually is. And then you got the subtropical ridge ridging into the eastern United States. Low pressure system moved through, a frontal system moved through. Looks like you're getting this high pressure just kind of getting absorbed into the subtropical high, because that high would be one that pushed down or from the west that was behind that cold front. So that was the high pressure. So it looks like the frontal system to me is undergoing frontalysis, and then the high pressure system is going to start getting absorbed into the subtropical high, and that frontal system starting to dissipate. So let's get with put the isotherms on here. Then we'll do station plots. See, we have thermal advection up in this area. Weak for the isobars. It's weak thermal advection here, and really nothing. And then if you brought that cold front out, you'd almost have to go stationary if you separated that high. You'd have to push a stationary front through there, because you don't have the thermal advection to back it for to actually bring your cold front back around this with that high. Like I said, that's undergoing frontalysis. Alright, so station plots, like I said, on the surface you want to run about 85-87% at the most. to be able to read this data. This is with the whole United States. Now, if you're zoomed into your state, say Missouri, you created a map, and then you went to location preset, you can pull up Missouri and then create that map, and that would actually just bring up Missouri only. Then you would want to go up to 99, 100% for that state, so you get every station plot you can get. All right, so I see a low pressure system over the central U.S. This is the lee side of the mountains, lee side of the Rockies, along the Continental Divide. Thermal ridging, high pressure, winds from the south, but this pressure gradient isn't very tight, so we don't have a lot of major thermal advection. Now, we do have dew points in the 70s, 60s, so looks like scattered to broken skies based on those surface plots there in the south. But I'm trying to stick with the software anyway. I'm not going to get too deep into the forecasting or the chart analysis. I mean, I always veer off, so wherever this leads, it leads. All right, so we want to put fronts on this thing. What the fronts are going to do also for the NCEP is going to be, it's going to put lows and highs on here too. So it's going to double those and put them in different places and then put the fronts on. So it can get pretty cluttered doing that. So we'll click on data and then we go to fronts. So I want the data, fronts from NCEP or user input. So if you go to user input, you can actually go to fronts. You could draw. So you draw mode, and then you got view fronts, start a new overlay. Sometimes this program gets a little confused. I always start a new overlay and then start plotting my fronts on there, because this software will kind of crash and then it won't shut down on you, but the front processing will shut down on you, so you'll be stuck with what you got. So this, like I said, all these lows, highs, fronts, just fronts everywhere. So we're bringing a cold front out of that low, which it should be coming out of this low based on that wind shift. Looking at maybe some temperature changes. There's a 72 and a 60, so bring that cold front back, but you're not going to bring that cold front back all the way through this high. You're going to have to go stationary. They got almost a stationary front. This is like a warm front, stationary to warm, cold to warm to cold, almost stationary with a post-frontal trough. So whatever you want to call that. Now, this low pressure system over the central U.S., you got a warm front. Looks like that high pressure is kind of blocking it, so it's bringing that warm air, that warm front down to the south, like a cold air damming. But you do have some thermal advection there, and then front troughing behind that low. Like I said, pretty cluttered. Now, pretty much get a lee side trough with that warm air advection. Any warm air advection in this area, you're going to get a lee side trough, or the air falls off the mountain, the colder air falls down off the mountain, compresses and warms and creates a lee side trough. So you can get that also. Occluded low to the north, whatever, if you want to buy that, we'd have to look at. There is some pretty significant thermal ridging, so if you're going to put a occlusion there, you're going to bring that occlusion out of a low through the thermal ridge. That's the placement of the thermal of the occlusion. All right, like I said, this gets pretty cluttered. Another thing to do is if you go to analysis, pressure, and you can go sea level pressure with no highs and lows, and that'll just put your contours or your isobars on there, lines of equal pressure. Then you can put your the isotherms, lines of equal temperature, station plots, we're 85%, so it shouldn't take long. And then go to data, go to fronts, and that will put your lows and your highs and your fronts on there without the few extra, So this one's pretty cluttered today. So the computer NCEP didn't process that very well. But there's your fronts. That's your surface chart. If you want to remove the last item, you go Window, remove last plot, last product, or you're going to plot last product. Now you can do allow digital atmosphere to run in the background if you're downloading charts from that data, the chart retriever. I don't use that. So, alright, that's our surface. Let me go back one more time. If we just look at the thermal advection, you're going to have got a warm core system to the south, just this warm pocket. So we could have a low pressure system form up down there. You got these lee side lows, warm thermal advection over central and eastern Texas up into Oklahoma. If we look at those dew points, we said we had dew points in the 60s and 70s. So if you got that thermal ridge there, warm air advection, the warm front would drop south, and then you have dew points in the 70s. There's 56 or 70, 47, 37. So you do have a dry line right through. Looks like western Texas. So if that dry line pushes to the east, then it could interact with that moisture. You do have scattered to broken skies, so we'll get into the upper levels and see what's going on there. But this low pressure system, closed low, 1003 millibars, starting to fill, and then that cold front isn't extending very far. I mean, this is some weak, very weak, no thermal advection. I mean, you have almost a cold front. There's 57, 58, 63, 66, 55. Really not much of a temperature difference there to even bring a cold front out. But if you had any kind, really you got a east, looks like a westerly flow, so look for that wind shift. Here's a wind shift right there, and then calm winds, calm winds. So like I said, weak to no thermal advection. This low is filling. That frontal system is undergoing frontalysis, and all that is going away, pushing off the coast. You still got some moisture associated with that over the Great Lakes region and over the Northeast, the New England states. Alright, so let's go to the upper levels. Actually, let's go build a thickness chart real quick. I want to pull up one of my scripts for thickness, and this should automatically build this chart. Alright, so looks like a cold pocket over the mountains, just the lower heights. We had that warm pocket to the south, but I'm not really seeing that. I'm seeing a wind shift there. Now, if we look at any thermal advection here, we're going to have warm air advection because we got higher heights being advected into lower heights. We've got our 540 line. That's our rain snow line. 5,400 meters. So that actually cold air is dropping pretty far south right here in this low. I mean, your thickness line is pretty far to the south for this time of year. So you have a high pressure system, so your heights are there. We have real shallow heights in that area. Alright, so if we had to go with a frontal system, I would say, like I said, that's undergoing frontalysis. This one, up into this thickness ridge, I would bring possible warm air advection right in that area, just because you got higher heights being advected into lower heights. So I'd place that front there. Now here's the tightest part of your thickness packing too, if you can see that. That's where the jet stream would be. So your jet is going to go around that high. So you do have a long wave trough, and then that's going to be basically support for these systems. Alright, so there's a thickness chart. Let's go to I usually run a set upper air. Now to get these scripts, you can go to if you go to weathergraphics.com, go to the software or go to data or something, and then go to support. You'll see a forum. You can get into that forum, and there's a lot of the scripting in there. Now I had to modify a lot of it for the colors I wanted, for the data that I wanted, but you can find pretty much all this script in there. So I'm going to open this one, run the set. This is for the upper air. So actually, what I should have done first was go back to the station data, and I should have bumped that up to 99%. But this shows upper level moisture, contours, isotherms, and then the station plots that are the radio sound data. Then I'll go build a jet stream at 300 millibars to see where my jet maxes are, so I can judge where upper level divergence convergence is associated with those lows and highs. So let's go back real quick. Go to the work chart. We'll click on go 99%. If you go to 100%, sometimes on the 300 millibar like this, you'll get two plots and they'll get a little bit cluttered. It's like this one here has two wind barbs on it. That has two wind barbs. So even at 80 some percent, it gets a little bit cluttered. And that happens sometimes too by downloading all that data. When you retrieve data, this radio sound data, you start clicking on all these, you get more data than it can process, so it just overlaps it. So I'm going to run this set one more time, and that will just overwrite the charts on the surface on the actually on my desktop. That doesn't take very long, so if we go, should be at 300 now. And just by those winds, you can see that ridging and then the troughing. So you get a pretty good idea on the jet stream placement. Now, if we go to the work chart, let's go up to 300. Then go analysis, wind, and then now these you have to, when you run pressure, you have to run height or a balanced height field. You can run thickness, let it run your thickness lines. 500 millibar height, it's just the same thing as a 500 millibar. If you change this over here to 500 and went to the height, it doesn't, there's no difference except for the color. I think it puts a lighter, like a light blue color for the contours. Altimeter setting, pressure tendency, pressure. I don't use a lot of this stuff. I used to use I use the heights, but first thing I want to go to is wind. Now you could do temperature shaded. That's in Fahrenheit only. Then you can do your 6-hour mins, max, and 24-hour min max temperatures also. So moisture, you can do the dew points. So you're on the surface, you can do isotherms, which lines are equal dew point, Fahrenheit, Celsius, where you can do a shaded dew point, so you can actually see where right at the 60 degree Fahrenheit dew point, which is critical for severe weather, it will actually do a shading on the chart, and then you can see your area. Any severe weather should be where it's 60 degree dew point or higher. So let's go to, we're at 300 millibars, so we're going to go to wind. You can put your barbs on there, your wind vectors, Like I said, there's a lot you can do with the software. I don't get that deep into it. The more complicated you want to make it, the more complicated your forecast is going to be. I try to keep things simple. So I do wind shading, upper level knots. Then I'll go back to analysis, pressure, go to height, go about 300 millibar contours on there. And then I'm at 99% because I'm on the upper level charts. So I'll hit my station plots, the radio sound data. Like I said, anything on the green, I think is like 25 knots. The yellow looks like 35. Red is your jet maxes, so that's what you want to see when, like this jet max, you know that low pressure is going away. You got a jet max way to the south, and then that jet max is moving out of this trough, so that trough's starting to fill. Weak jet max right there, and then we got a jet max over the Pacific Northwest. So you got an idea what your your jet stream, where your jet stream is. Now you can also go to analysis, go to wind, and put streamlines on there, and then you can see the streamlines of your jet. So you can see your ridging, troughing, ridging, troughing. Alright, so if you want to go higher, go to 250. Wind shading. Still got a pretty good strong jet at that level. Now if you want to pull like a low level jet, you're looking for severe weather and you need low level wind shear or a low level jet, you can go to 850 and then you can run this upper level wind shading, and you can see that too. Now that doesn't always work. There is actually a script for low level wind shear, so that's the one I use. Let's go to 850 real quick. If the wind speeds are there, it will actually show you. Plotting all the different speeds. There's really nothing there on the 850. Alright, so let's get out of that. Let's go to, I usually put that on surface. I want to run. Let's go to low level wind shear, see what happens. Low shear. Alright, so we do have a low level jet down here, or low level wind shear in the southeast. Right there over the northeast Colorado, also just a little weak shear there. So if we look for a dry line to move to the east, we have this dew points in the 60s. You know, let's go to the SPC site and we can see if they're looking for any severe weather in the southeast over the next couple days. Let's pull that up. We go to alright, over northern Texas and southern Oklahoma. A little bit of a chance over southern Florida, and then a slight chance to the north over the Dakotas, Nebraska. So if we get in those areas right there, Nebraska, that looks like that pushed a little bit to the north. This is a little bit stronger than. Now this is just low level wind shear, so you can't go by just one item. You got to look at a bunch of them. Let's go to a theta E advection. We'll look at a Kelvin temperature advection. Let me run that. See what I got here. Let's go to this one. Alright, so southern Texas, a little bit over Nebraska into the South Dakota, Iowa. So there's a potential there. Pretty weak. Now, there's where your thermal, that's where that warm pocket was down there over southern Texas. So if you, if that was to interact with anything, then you could get that severe weather in that area, especially with that low level jet. If this was further to the east, then with that low level wind shear, then you could definitely have some severe activity over there. So that's probably why the SPC is really not calling for that. Let's go out here to get over there, get to the right screen, and then pretty enhanced over the Dakotas and the Minnesota. Same thing all the way back up in the Minnesota. Looks like possible derecho weather right there if that turns out to be. So let's go back. So that looks like a pretty elongated severe weather right there. If that was to happen with straight line winds or something in Iowa like it did a few years back, that could cause some damage. But definitely keep an eye on that the next. That's for day 3. So if we go to total severe probability, that's 30%. And enhanced risk of severe thunderstorms in eastern North Dakota. Alright, so let's get back to our software. Let's run, stretch this out a little bit here. We can run potential precip. Like I said, I downloaded all those scripts from that forum. I haven't modified all of them yet. I just have them in here. So we can do just upper air moisture. That's the moisture that you see on the charts, the upper level charts. Water, snow lines, wet bulb, wind shader, wind chill, stability indexes. Those are okay. They're not the greatest. We can go with total totals. Look at that. Pretty much nowhere we're expecting any severe weather. Winds flow out of the south. Alright, let's get rid of that. Let's go to. I don't use them a whole lot. I use them every once in a while when there's there is an area of significant area of severe weather. So kind of just see what happens with those. They're not 100% accurate. So, and plus this data is real-time data right now, not it's the SCOOT data from for 0Z. So it's not a forecast. None of this data is forecast at all. Went to go to the charts, to the forecast charts. I usually go to College DuPage for the weather models. I think it's a pretty good weather models they use. Here's one, surface frontogenesis. So let's go look at that real quick. It's going to show us any area where the fronts are going to be enhanced, a chance for these fronts to intensify. So right here, all through those lows, pretty good chance through the central U.S. Now, right through there, I would call that stationary to nothing. Your major frontogenesis is going to be out to sea, so this would be going on frontalysis. Another thing I add on this one is I'll add the pressure, and then the sea level pressure with no highs and lows because we already got highs and lows on there. Then I'll put my isobars on there. Now you can actually see the high and low centers. Just it gets too cluttered with the fronts anyway, so it really doesn't matter. Alright, so let me go to 500 millibar. Low pressure to the north. or high pressure to the north. What we got? 5400, 5460, 5520. So we're going into high pressure. So we got low pressure well to the north. That's the support for that low pressure system that's in the northeast. Let's go over here. 300 millibar. There's a closed low. 500. It'll go back down to 700. Now you can see moisture in the northeast all the way up to those levels. Now these stations that don't have, they're not colored in, you can pretty much take all that moisture away. The computer overanalyzed for this. It usually goes for about 60% dew point. Relative humidity where it puts the moisture. So the time of the moisture could be different from the 0Z chart. So like this is a 0Z May 29th. That's a 0Z data. Now this is where the colored ones, that means your dew point depression. The difference between your dew point and your temperature is less than 5 or 5 or less, and that will put moisture on the chart. So you can say you got moisture in the northeast, moisture over the Great Lakes region, and then moisture over the northwest. Pretty significant moisture up there. Everything else you can kind of ignore. Alright, so the 850, you got an open low, moisture to the north, all that through the northeast, cloudy all the way through the Ohio Valley. And then that moisture starts to dissipate in the upper level, so pretty much had a bunch of low clouds in the Ohio Valley, and then significant moisture in the northeast. So the cloud thickness was pretty good in the northeast. And then this was all cleared out in the upper levels. Great Lakes region had some moisture going to the upper levels, and you were back up to 300 millibar. So we're moist all the way up in the Great Lakes region at least, and then into northwest. So you can see that all the way through, and then we get to the 850. Really, that clears out on the lower clouds because that's 5,000 feet, and then you got moisture at 700 millibars, which is about 10,000 feet. So in your mid layers, you got significant moisture in the northwest and the mid layers. So this is just one other tool you can use for clouds, types of cloud types. What ranges are at, the mid range, high range. Which cloud etage you were looking at. All right, so. I'm not going to cover the software. I actually hit that button. This is Sloop Data. You can go download this data, and like I said, download the latest Sloop. I'm going to do it real quick. We're just going to hit it. I want to download Wilmington, Ohio. It takes a second, and then we want to open. Now we got Sloop data forecasts all the way out to May 31st, June 1st, Wednesday at 1 a.m. So we can pull a Sloop all the way out to that. And I believe this is the NAM. So we are going after 0Z data for the 29th. That's the latest data that we're actually working on right now. So right there would be 12 a.m. We don't want that one though. That's local time. 0Z 7 p.m. That's the one we're after. Alright, so now we can see we got moisture in the lower layers, and then we get dry throughout the mid layer, pretty much all the way up. So we had some low clouds out here today. Sun was shining pretty good later on in the day, so this pretty much broke off, and then finally got rid of all the rain. So it's high pressure setting in. You can see the temperature and dew points. You can see the difference between the temperature and dew point, and that's going to show you how dry it is in that layer. And then there's so much more you can do with this software. We can actually analyze this data. Run our cape. There's a little bit of cape there. That's for severe weather. Obviously, we don't have any threat in Ohio. Low level wind shear. Clouds, lightning, contrails. There's a layer of contrails, 25,000 feet and up. Any inversions? We do have an inversion right here. So that's going to cap any of that moisture, keep all the low clouds to the surface. Mixing height, freezing line. You want to see where your freezing level is, about 600 millibars. Right here is freezing level, 13,000 feet. Alright, so anyway, a lot you can do with that chart. We'll cover all that stuff later. Get back to this one. Alright, so that's pretty much all I use on this thing. I don't go too deep with it. Now, actually, let's go over here. Let's go to, let me get my bookmarks back up. Go to the National Weather Service radar. I want to go to maximize the screen. Let that stuff clear out. Now I'm going to copy this screen. I usually start about right where the E is. I run about it's right around 1200 by 640 resolution. About actually 1240 by 640. So if we do 1239 by 640, it usually does pretty good for what we're doing. So let's save that. Go create a new folder. So 28th. Alright. Actually, let me go. Import map from file. Okay, so digital atmosphere has no way of determining projections or coordinates from the image you are about to import. Therefore, projections and coordinates from the last image will still apply. Do you want to continue? So hit OK, because you're just importing a map over this thing, and it has no idea what you're importing. That's all that's saying. Alright, so go to PNG. Let's go up. Go back to 528, and then we're going to go JPEG, actually. Go there, and now we uploaded that. Alright, so now what I wanted to do real quick, let's go to, just to clear it out. If I recenter it, to clear it. So let's just clear that off for a second, because we're going to have to recenter this map to match the map I want to import. And typically right here, where that hump comes out from Louisiana into Mississippi, right there on that hump is about where I want to recenter. Let that process. Do not move the map while that's processing. It will actually scatter the lines. Everything will go crazy. Alright, so we have to put our logo back on there and all that stuff. I'll show you how to do that in a minute. Alright, so now I want to import map from file. Hit OK for the warning, and then it puts the map over top. Now for get the darker lines back on here, we're going to go with an overlay. We'll overlay the base map. Alright, so see, that lines up pretty good. Texas lines up almost perfect, pretty much all the way up to coast of California. You have a very, very, very small gap to up north, but everything pretty much lines up pretty close with that 1249 by 640. Alright, so now right click on this. I want to add my symbol, put my logo back on there, and then one thing you got to do before you do anything else is hit map, copy markings to base map. That's going to save these lines, because if you don't and you put that on this chart and then you erase it or move this chart, you're going to erase everything. So now you can't recenter. If you recenter anywhere on this thing, it's going to erase all that. Take that whole picture off of there. Alright, so now we have the latest radar screenshot. go to the surface, make sure we drop our data back down to 85%, and now we can go sea level pressure. Overlay that right over top of that system. So now if you notice the other low is gone, let's close that low off because of where we recentered the map. We're recentered, so now the analysis actually changed. So it'll give us a little bit more accurate analysis. So we have that lee side low, that low pressure to the south. There's your thermal ridge. You got your wraparound, and you got all that moisture over the Dakotas. So we can see the radar along with the surface map, and then we put our station plots on here. So now we'll be able to see there's our moisture, all of the darkness, overcast skies for these latest station plots that were downloaded, and then weather types. We got rain, rain reported there, and then you can see your temperatures, dew points, and you can see your whole weather system associated, where the weather is associated with those systems. So that makes it pretty nice there. Alright, so I usually label that. I can label it surface. Now, you'd have to put, like I said, you got to create your own bitmap images. I got, like, add symbol, 1,500 millibar. That's my thickness. I got another thickness down here, 200, 250, 35. The vorticity chart, actually, we'll pull a vorticity chart too, and that gives us a pretty good indication where the rotation is in the atmosphere. You can do cloud, that's the default when you download the software. Cold, that's just it just says cold, and it's a little icon I downloaded years ago. Hot, frontogenesis, that's from my frontogenesis chart. Lapse rates, so I can run the lapse rates chart. Low level wind shear. I got my logos, mid-level wind shear, surface winds. Surface is what we just put on there, and then thickness, if we want to label our thickness chart, and then windy has a little tree blowing over. That's just stuff I put in there just to, as I was experimenting with this, like the windy, the hot, the cold, stuff like that. So, and then I started creating my own to label these charts. Because I do save a lot of them. If you notice in that folder that we went to, I do have quite a bit of weather charts saved. So sometimes I'll download them, everything for a week, and then I'll go back and analyze what happened, what type of weather in what areas, and then that just helps you with a forecast. I don't write too many forecasts anymore. I was an aviation forecaster, so I had to write forecast pinpoint for one weather station, and then verify forecasts for any other weather station that the aircraft might have went to, any airfield. So you had to go pretty deep into detail on a forecast. It wasn't ever like 30% chance of rain. We never even used that. But it's like, is it going to rain or is it not? What's the cloud height going to be? Because if a cloud height's below 3,000 feet, you're changing rules for pilots. So you drop below 1,000, you're majorly changing rules. Visibility 1 to 3 miles, or dropping below a mile, then you're changing rules for pilots. So now, you got to be accurate with your forecast with that morning fog, what time it's going to dissipate, inversion overhead. You got EOD dumping, ordnance disposal. They're blowing bombs, just to dispose of that ordnance. And if you have an inversion present, you're blowing out every window in the base. So you got to know when that inversion is going to break. You got to know when the fog is going to dissipate. You have to know how to forecast every weather parameter. It wasn't just a general forecast for a general area. Alright, so a lot of other forecast models you can use for that stuff too. But you got to know what you're looking at on these charts to verify all of that model data first. You can't just say, okay, it's a low pressure system. Well, what's that mean? What is this, 993, low pressure center? Okay, what's that mean? So we'll start covering some of that stuff. If I get time, that's my biggest problem. I haven't done a video in a while, but if I get time, I'll start going through types of weather systems, what to expect from them. We'll look at the atmospheric circulation. You got to look at every aspect. Jet stream, where according to the jet max that low pressure system sits, if you're going to have upper level divergence or upper level convergence to intensify that low or fill that low. So there's a lot of data you can use. So I'll try to get to some of that. I'll try to keep those videos short, just straight and to the point. But I'll start hitting them here pretty soon, and we'll just kind of do the forecasting aspects of the thing. So let's go look at. If we erase that, we still maintain our radar. Now the only time we'll lose this radar is if we recenter the map. So now if you run the upper air data, you have to recenter this map. Just because, get rid of this overlay. That radar will clash with that moisture you've seen on the upper level charts, so it's not going to look pretty on here. Here, let's go run on real quick. Run that upper. If we run the upper air moisture, actually it's not going to do anything, probably because I'm on the surface. It might run surface moisture, but let's see what happens. Yeah, so you see how all the greens clash. That's looks pretty nasty. So pretty much that's why if you run the moisture in the upper air charts, you're going to want to get rid of this chart, get rid of this radar. But I did come pretty close to getting that size down for the chart size. I could probably shrink it a little bit for the length. Actually, probably expand it just a little bit on the length to bring that over, and then same thing with the top too. Probably expand the chart just a little bit more. We'll probably bring it right into where it needs to be. But this is actually pretty close, and it puts me right there on that hump for Louisiana to right click and center on that. Alright, so climatology, you can extract data. I don't usually mess with this too much. So you go the daily high for January. Or an annual high. Let's see what happens. Alright, custom data field has been created. We now view it. So view the plots. There's your, it's pretty much for the annual. That's pretty cluttered. You have to be zoomed into your state to be a lot better for that climatology data. Let's go look at let's just say for May. Probably gonna do the whole chart again, so it really doesn't matter. Days with thunderstorms for May. View that. Okay, so for May, here's your average days with thunderstorms. All right, so another thing was so there's that convective outlook. That, like I said, that doesn't work. Let's go. You can pull a sounding here. I got the other software for that. I don't really use this one, but let's go look at this real quick. This one's been wrong for a while. I don't know if there's a link broken. Let's see what this does. USA, Cincinnati, Wilmington. Alright, there's that. Pretty much doesn't look like the one we looked at, so I wouldn't trust it too much. Alright, let's go. Let's see, precipitation, thunderstorms. Alright, so that's pretty much May thunderstorm days. Okay, real quick, let's go to historical data. I do have that downloaded. So if we go to map, let's see. We'll go to, which one was it? Import historical data. Now we can pick a date. I'm trying to think. $1993. Let's go May 14th at, let's see, 12Z. Import that. Okay. Successfully imported. Now we can do sea level pressure. That'll show us our lows and highs for that date. This is back in 1993. Alright, so isotherms. Now this data, 85%, depending on the year and how much data was actually collected, this can get pretty thin, so sometimes you'll have to bump that up. But there's the surface chart from 1993, May 14th, 1993. So historical data is pretty cool. You can actually pull those systems for significant weather that you know about. Pull up a historical storm, and you can actually pull the data every. It's only on 12 hours. It's 12Z and 0Z, so you can pull that through every 12 hours and watch that system move through and see where it develops. So I'm gonna recenter my map. The recenter of the map right here where it says United States, right north of that, and south central Nebraska. Right click, recenter. That erases everything and puts you back where you were. Let the map continue to draw until it's finished before you move the scroll bars, because it will kind of shift those lines and just put lines through the screen and do some weird stuff. So you gotta let that continue processing. Put the symbol back on, map, copy markings. So now I'm saved. Alright. So now to get back to your data, you'd have to go back and retrieve your data again to get the latest data, because we're still on 1993 data. Alright, so that's pretty much it. If you have any questions on the software, let me know. If you want to get some of the scripts, if you end up downloading the software, purchasing it, and you want any of the scripts, let me know. Try to figure out. Just comment on the YouTube, and then we'll work out a way to do a DM or something to send you the scripts. So let me know. Like the video, subscribe, and visit my website, Meteorology 101. And until next time, get your head in the clouds.